All right, let's talk about something we all think we understand: electricity. We're going to pull back the curtain on this one and reveal a truth that's, well, a whole lot stranger and honestly way cooler than what most of us learned back in school.
So let's just start with a question that sounds completely nuts, but it gets right to the heart of everything. Is the device you're watching this on right now, are the lights in your room actually being powered by the empty space around the wires? The answer? Well, it might just blow your mind.
You know the story we all get taught. An electric circuit is this closed loop. The wire, that's just a pipe. And these tiny little electrons are like water, flowing out of the battery, through the pipe, to the light bulb, and bam, the light turns on. It's simple, it's tidy, and it feels right.
But that analogy, as useful as it is just that, an analogy. It's a useful lie that helps us get started, but it's fundamentally not how electricity actually works. It hides a reality that's so much weirder and so much more amazing. You know, the first big clue that the whole water pipe story is off is the actual speed of the electrons. They move at a crawl. We're talking about 1 millimeter per second. A snail is faster than that. If they were the ones carrying the energy, you'd flip a switch and then, I don't know, go make a sandwich while you wait for the light to come on? Clearly, something else is going. And here's the thing. This isn't some brand new discovery. To really get what's happening, we need to jump in a time machine and go all the way back to the 1880s. Physicists back then were staring down a massive contradiction in their own theories. See, they had two totally different but equally correct ways to calculate electromagnetic energy. One formula pretty clearly said the energy was inside the wire, moving along with the current. But another, equally valid formula said the energy was outside the wire, living in the magnetic field around it. So which was it? It can't be in two places at once, right? This whole mess forced them to ask a really basic question. When you hook up a battery to a light bulb, where is the energy that makes it glow actually traveling? The answer was about to change everything. So enter the first hero of our story, a physicist named John Poynting. He looked at this contradiction and decided he was going to get to the bottom of it. He just wasn't buying that energy magically teleports from one place to another. He asked this simple but incredibly deep question. He was like, okay, let's stop guessing. How does the energy actually travel? What path does it take? He wanted to draw a map of its journey. His answer was this brilliant new idea called the Poynting vector. Here's the gist. The battery creates an electric field that pushes out into the space around the wires. At the same time, the current inside the wire creates a magnetic field that circles around it. Poynting showed that wherever those two fields cross, that's where the energy flows. The energy wasn't in the wire, it was out in the fields. And this is where it gets really mind-bending. When you actually map out the Poynting vector for a simple circuit, you find that the energy doesn't flow down the wire at all. It flows from the empty space around the wire and dives into it from the sides. So this is the key. The wire isn't a pipe carrying energy. As Poynting himself put it, it's more like a drain. It's the destination where all this energy, which is flowing through the space around it, converges and finally gets turned into heat and light. Okay, but Poynting was just the beginning. Now we need to talk about the main character of this story, a brilliant, kind of difficult, and mostly self-taught physicist who took this weird idea and used it to rebuild physics from the ground up. Meet Oliver Heaviside. This guy looked at the original equations of electromagnetism from the great James Clerk Maxwell, and he didn't see perfection. He saw a tangled, complicated mess that was almost impossible for a regular engineer to actually use. So what did Heaviside do? He decided to fix them. He took Maxwell's dozen-plus equations and completely reforged them. He boiled it all down to the four beautiful, powerful equations that, ironically, we now call Maxwell's equations. It was one of the greatest cleanup jobs in the history of science. But listen, this wasn't just about making the math look tidy. Heaviside had a much bigger goal. He wanted to completely shift how we think about physics. He wanted a theory where the fields, and the energy flowing through them, were the stars of the show. And this wasn't just some academic squabble. This new way of thinking about energy solved one of the biggest, most expensive tech problems of the entire 19th century. Back then, trying to send a telegraph or telephone signal over a long cable was a total nightmare. The signal would just turn into mush. It would get stretched out, distorted, and become completely unintelligible. And the old water in the pipe model, it had zero answers. But Heaviside, with his new fields-first approach, saw the problem in a totally different light. He said, "You're all looking in the wrong place.
The signal isn't just in the wire, it's an energy wave traveling in the field, guided by the wire. And he realized that if you just tweaked the wire's properties to balance the field, specifically by adding inductance, the wave would keep its shape. Problem solved.
You'd think people would have thrown him a parade, right? Ha! Not a chance. The establishment, led by this guy W.H. Preece, the top engineer at the post office, absolutely hated his ideas. Preece called Heaviside's work rank quackery, and even blocked one of his papers from being published.
Well, decades later, guess who was proven right? Heaviside, of course. And today, we don't have to just trust the math. We have computers that can actually simulate this flow of energy. We can literally see it for ourselves.
And there it is. Just look at this simulation. These lines show you where the energy is actually going. It's pouring out of the battery, arcing through the empty space around the circuit, and diving right into the resistors. It's exactly what Poynting and Heaviside were talking about over 100 years ago. The energy is in the field.
So what's the big takeaway here? It's that we've been looking at circuits completely backwards. The wires are not the highway for the energy. They are the guardrails. Their job is just to shape the invisible field around them and guide the energy that's flowing through the space between them.
This really should change how you see the world. That empty space all around you right now, it's not empty at all. It's a medium, and it is pulsating with the very energy that runs our entire world. It just makes you wonder, doesn't it? If this incredible truth was hiding in plain sight the whole time, what else are we missing? What other ways of moving power are just waiting to be discovered?